Okay everyone, welcome to Luthierism channel. This is the YouTube construction video for the Super Strat. So it basically is a humbucker with two single coils and a super switch. Super switch meaning it has 4 poles. Each pole has 5 pins. So there's a lot of different wiring configurations that you can come up with. On this one, there's a humbucker and 2 single coils, and what you'll have in position 1, you'll have a full humbucker. In position 2, you'll have the north coil of the humbucker and the middle single coil, and those will actually be out of phase. And I'm doing that on purpose because it's just an extra sound that you can get out of the instrument. So when you're in position 1, it's a full humbucker. Everybody knows what that sounds like. Position 2, it's an out of phase, basically 2 single coils out of phase, which gives you a really tinny, hollow sound. And I don't know, for some applications, it just sounds good in some music and some songs to have that arrangement. And then the third position is just the middle pickup. Fourth is the middle and neck. And then fifth is just the neck pickup. So that's basically what we're doing here. And, one thing also, I'm using all pushback wiring, full-size pots. And, the pickups are not, they're good quality pickups. I mean, they're not a real known high-level brand name. But I almost find that if the wiring and the electronics are premium quality, that's almost more important to me than the pickups. I mean, yeah, the pickups are, you could take really expensive pickups and put in, dime-sized pots and cheap wiring, and I don't know if you'd be able to get all that you can get out of them. I mean, to me, it's like, when you think about what's happening in the instrument, you're creating a very small signal and you're channeling it towards the output jack, and then it's picking up that small signal and amplifying it. Well, if you have really good conductivity and really good pushback wires and good potentiometers, and you've balanced everything with we're going to balance the resistances with the different pickups, and just use good quality conductivity, I think you'll get a really nice sound, because I put all the best components in this guitar, and when you play it, it just sounds, I think it sounds fantastic. And towards the end of the video, or towards the end of the next couple videos, I'll do a little bit of a playing demo, and we'll take a listen. But I have noticed a really big difference by using the best quality CTS pots, full-size potentiometers, pushback wiring, good quality capacitors and resistors. It makes all the difference. So let's move on to the next part here, which is the parts list. So what are we going to need basically to wire this thing up? So now we're going to get into the parts list for the Super Strat. So the first column is the part, and the second column is the number of individual parts required. So when we build this, we're going to have a humbucker and 2 single coils. So we're going to need two 500 k ohm Chicago telephone supply CTS potentiometers. We're going to need 2 of those, and we're going to need 250 k ohm CTS potentiometer. And an Oak Grigsby Super Switch 5-way double wafer. So that's basically 4 poles, 5 pins per pole, plus commons. And we're going to need a cloth pushback wire, 2 colors. I'm going to use yellow and black, I believe. And then we're going to need a 0.022 microfarad capacitor for the 250 k ohm tone pot. And then we're going to need a 0.047 microfarad capacitor for the 500 k ohm tone pot. And then we're going to need a couple 470 k ohm resistors, 2 of those, to balance out the volume pot, which is 500 k ohm, and the 250 k ohm pot that will be used as a a tone pot for the single coils. So what we're doing here is we're balancing out. We're adding the 470 k ohm resistor in parallel, and what that will do is take away some of the brightness. So usually when you're wiring up single coil pickups, you're going to use a 250 k ohm CTS pot because you want to warm the sound up a little bit. And the 500 k ohm pot on the humbucker actually brightens it up a little bit. It's actually the opposite because you're wiring those things in parallel to the circuit. So I'll show you as we get through a little bit further into this. But so when the volume pot is a 500 k ohm, and when I'm working just the single coils, I want to balance it out so the single coils see a 250 k ohm volume potentiometer and a 250 k ohm tone potentiometer. So you do that by adding in those 470 k ohm resistors, and that will make those pickups think they're seeing 250 k ohm volume pot and the 250 k ohm tone pot. So I'll show you how that works as we get through this a little bit. And then I'm also going to put in a treble bleed circuit, which is a 0.0012 microfarad capacitor in parallel with the 150 k ohm resistor. And basically what that's doing is it's allowing the high frequencies to pass through and not be squelched as you increase the resistance of the volume potentiometer. So, when you turn down the volume on a regular potentiometer, you lose some of that high end. So what we're trying to do is retain that high end as you turn it down, and that's what the treble bleed circuit is going to do. So let's just move on here, and I'll show you what I'm talking about. So just a little bit about the resistors. Resistors and series are additive. So if you have resistor 1, 2, 3, and 4, 5, 6, you just add the resistances together to get the total. We're not doing that here. We're basically looking at in parallel. So when you look at resistors in parallel, there's a general equation for finding the total resistance, and it's usually the resistances get smaller. The total resistance gets smaller as you add more and more resistors in. But there are two special cases when you have two resistors in parallel. So this is kind of an example of a 500 k ohm potentiometer and a 470 k ohm resistor. So we're trying to utilize the single coil and try to utilize the 250 k ohm pot and the 500 k ohm pot, which is the volume, and the 250 is the tone, and the 500 is the volume. So we're trying to balance that out when we're using the single coils. So what we're really doing here is all you have to do is take R1 and R2. So if R1 is 470 k ohm of resistance, and the other is 500 k ohm, and you just multiply those together on the numerator, and then add them together in the denominator, and you can see the third equation is what we're doing there. We're multiplying resistance 1 and 2, and then divided by adding R1 and R2, and that gives us the approximate total resistance. So you can see it's actually almost half because we have a 500 k ohm and a 470 k ohm, and if we do that calculation, the entire circuit or the single coil pickup is going to see about 242 k ohm of resistance. So that's what we're looking at trying to do. And then also, if you look at just the general, another special case is if you you have two resistors that are exactly the same. So if you have two 5K ohm pots or two 500K ohm resistors, it's just having it, taking half of it. So it's a special case. So if you have a resistance of 500K ohm and there's two resistors, so N is 2, you get 250 K ohm. So, and the reason why that happens is because when you add more and more resistors in parallel, there's more circuitry for the current to flow down easier, and so the resistance is actually lower. And then if you look at the third case, which is the general case, so if you have 1, 2, 3, 4, 5, 6, 7, however many resistors, what you do is you take the inverse of the inverse. So the R total is 1 over the inverse of each one of the resistors added together. So you can see the calculation is pretty simple. And what we know is the total resistance will actually be less than the smallest resistor. And that's just because you're adding more and more parallel circuits, and you're providing more pathways for electricity to go down the circuit. If you imagine the circuit in your mind, there's just more and more pathways for current to flow, and the resistors are not in series where they're almost like a backstop or squeezing off the current. They're actually in parallel, so you have these parallel lines where the current can kind of move freely down the parallel lines. So that's the general case. So I mean, to make a long story short here is that we're adding in these two resistors, so when we're accessing the circuit where the single coil is located, we're balancing the tone pot and the volume pot. So the single coils see 250 K ohm and the humbucker sees 500 K ohm in parallel. So, and another strange thing too is the 500 K ohm resistor will actually lower the resistance of the circuit if it's in parallel, and the 250 K ohm resistors in parallel will actually make the single coils a little darker. So it'll actually add a little bit more resistance to the circuit, and the humbucker with the 500 K ohm potentiometer or resistance in the circuit will actually brighten it up a little bit. So it's actually the opposite of what you would think. It's a little bit counterintuitive. So let's move on and kind of take a look at what the circuit is going to look like. So here's what the overall general circuit looks like. And as you can see, you have a two tones and a volume. One's a 250 K ohm pot, one tone is a 500 and the volume's a 500. And the next image will show where the pickups come into play. But you can see there's 4 poles, so the 4 sets of pins, and there's actually 5 pins plus for each pole, plus a common for each pole. So when you look at this really close, hard to see, but you can see the 0 is the common pin. So when you're in position 1, number 1, all the number 1s are part of the circuit, and the commons associated with the number 1s are part of the circuit. So when you're in position 1, there's 4 1s, there's 4 zeros. The top bus is not labeled, but it's the same as the bottom lug poles. So you have 4 zeros, and then when you're in the first position, the switch is actually pointing to the back of the guitar. I'll show you that in the next slide. But so the common and number 1 on both sides, on all 4 poles, is connected. So basically what we're doing is we're looking at all 4 poles in the commons, and we're rearranging the leads to get 5 different positions live in an individual circuit. And I'll show you that as we go forward here. So now you can see that the circuit with the lead wires from the pickups on the circuit. So you can see the hot from the neck, the hot from the middle, the north start from the bridge humbucker, and then the north and south finish from the bridge humbucker. So now all the grounds are basically grounded to the volume pot here. But as you can see, as we go through the positions, 1, 2, 3, 4, 5, 6, it engages or puts a different pickup into the circuit. So if we go to position 1, like right here, the start from the north humbucker, basically position 1, if you look on this side, there's nothing there. And then position 1 on this side, there's nothing there. So basically position 1 is just the start from the humbucker. So the power is on 0 here. So the power goes through the humbucker and then to ground. So on position 1, it's just the humbucker. That's it, just the humbucker. And then as we go through the positions, I'll show you how it changes. But we start to engage different parts of the humbucker and then different single coils as we go through the positions. And I'll show you what the positions look like right now. Okay, now this is an illustration of the different positions. So if you look at position 1, there's a little black rectangle, and it says back of the guitar, switch position 1. So if you look at the upper left-hand corner of this diagram here, the first position is the 5-way switch is all the way back towards the back of the guitar. So those pins, if they're in the guitar cavity, are pointing towards the inside of the cavity. And here you can see that you can see all 4 poles, 1, 2, 3, and 4. The pole is all 6 pins, including the common, or 5 pins without the common. And you can see the way we have it wired in position 1, the commons for pole 1, 2, and 4 are hot, and the common, or the 0 lug for pole 3 is ground. So in the first position, we're at 1. So 1 and the commons are all connected. So in the first position, if we go back to it, if we remember, that's just the humbucker. So the humbucker is the black wire comes into 1 and goes to the it comes on the one position on pole 2, and then pole 1 and 3, the first position, those 2 lugs are blank. There's nothing attached to them, so they're not doing anything. And on pole 4, there's nothing happening there either. It's not going anywhere. So the black wire for the humbucker is going into pole 2, position 1, and then going to ground. So from pole 2, if you look at pole 2, you go from 0, which is hot, which is always connected to all the pins, but we're in position 1, so right now it's only connected to the first pin, pin 1. So the power is going to the north lead wire of the humbucker and going all the way through the humbucker, through both single coils in the humbucker, in parallel or in series to ground. So pole 3 goes to the volume pot. Pole 3, the green, goes to the volume pot. And as we go through, we're just manipulating this pin arrangement to where we're accessing different pickups. So when we go to position 2, you can see we're 1 up from the back of the guitar, and position 2 is engaged with the commons. Okay, and then position 3, all the 3 pins are engaged with the commons. So on position 3, pole 2 and pole 4, position 3 is live because we have power coming in pole 2 and pole 4. On position 3, on pole 1, it's live, and on pole 3, position 3 is ground. So you can see that we can go through this sequence, and we can kind of get an idea of how to install the pickups and what jumpers to put on the different pin positions in order to make it all work. And then when you go to position 4, you can see 4, these two, pole 2 and pole 4, position 4 is hot, and pole 1, position 4 is hot, and pole 3, position 4 is ground. So as we go through, you'll see that. And then the last position is just the next slide. It just shows where we are in the last position, and then how we can manipulate. So I'll show you how we can kind of like go through it and use different pin arrangements and different jumpers in order to get the desired effect that we want. It's a little complicated. You got to think it through, and you got to think, how does the circuit work? But I have a good visualization here that might give you a little bit of insight. It's something you're probably going to have to stare at for a while and really try to, get it right in your head. But once you do, it becomes easier and easier the more you practice. So this is the first position showing the humbucker. So the entire humbucker is engaged here. So we're starting on the north, the hot wire going into the humbucker, going through both single coils in series, and then coming out the green and going to ground. So you can see in position 1, and remember, the switch is all the way back towards the back of the guitar, towards the bridge of the guitar. You can see it here. Because when you turn this over and you mount this, these pins will be facing the inside of the guitar cavity, and it'll be screwed to the top of the guitar. So it's kind of hard to visualize that, but that was something that was really difficult for me to figure out. I had to think about it for a while, but basically, if you wire it this way, the switch is back all the way, and that lightens up, or that engages, or puts electricity to the first position. The first position. So I've got all 4 of the first positions engaged. So what does that do? Well, remember, this little jumper here is showing you that the common is always connected to whatever position you're in. So when we look at pole 4 and pole 2, the common, through the internal workings of the switch, is engaging pole 4 common, which is the red one here, and the first position on both sides of the wafer. Okay, so pole 1 is also in the first position, so it goes the opposite way. So it's when the switch is back, you almost think of it as it's engaging all 4 of the first positions, like this in this diagram. So what you can see here is that pole 2 is giving you a hot signal into the common, which is 0, and the internal operating of the switch is moving that hot lead to position 1. And that's putting it into the coil, and it's going through both coils, and then it's coming out, and it's going on the green wire, which is ground, and it's going to pole 3, because pole 3 is actually grounded to the volume pot. So and there's nothing hooked up to the first position here on pole 3. Even though that little jumper's there, there's nothing hooked up there. So this is the circuit. Based on how we have the pin arrangement, this is how the circuit works. So that's position 1 is just the humbucker, and that's what we want. So let me show you the next one. So this is position 2, and remember, position 2 is the 1/2 of the humbucker and the middle single coil. So it's basically 2 single coils. And the reason why that is because, as you can see in position 2, pole 2, if you look at pole 2, position 2, it's jumpered to position 1. And the reason why it's jumpered is that's because where we soldered the black lead, or the starting lead for the humbucker. So that's the starting lead. But instead of going all the way around the humbucker to the green lead, which would give us the entire humbucker, now we're going to the yellow and red leads together, and they're going basically to ground. So now it's giving us only 1 coil in the humbucker, 1 coil. So if you look at the middle coil now, the middle single coil, it's wired to ground, which is pole 3, and pole 3 is connected to the second position on pole 3. So both of these, the humbucker and the middle coil are both grounded there on pole 3 and position 2, and the hot lead is coming off of 2 because we're in position 2. And remember, the common on pole 1 is hot, so we've got a hot lead coming into pole 1. So now we have a hot lead on position 2 for the middle, and a hot lead for position 2 from pole 2 for the humbucker. And now we have, if you can think about how this works, we basically have one single coil from the humbucker and one single coil for the middle. And what I did was on this was I left it out of phase. Just on this position 2, I left it out of phase. Now if I wanted to be in phase, I would have switched the middle coil leads around because the humbucker is electrically at a different phase than the middle coil, and you can correct that just by reversing the wires of the middle coil. But I like the sound of the out of phase for just one position. So once I go back, so this is the only position where I have anything out of phase. The humbucker, of course, the entire humbucker is in phase. The entire middle coil is in phase, and the middle and the bridge, the neck. I mean, the middle and the neck are in phase, and of course, the neck is in phase. So it's just this arrangement that's out of phase. Now I could correct this and just change the leads on the middle and the neck pickups, but I don't know. I kind of like this because on some things I'm changing that really thin out of phase tone is kind of cool, and it's something that you don't really hear that often. So I kept it in there, but you could easily fix it if you wanted to eliminate it. So this is the position 2. So this is position 3, and position 3 is the middle coil wired in. And you can see position 3 on pole 1 is hot. And again, position the common on pole 3 is ground once again. So this is pretty simple. You can just kind of see that position 3 is hot, and we're just running one coil here. So that's pretty straightforward. So here we go with position 4, and position 4 is the middle single coil and the neck single coil. And you can see when you look at position 4 how it's set up. Pole 3, the common is still ground, so everything's grounded there. And then position 4 on pole 2 is hot because the common's hot, and the common on position 4 is connected to pin 4. So that's hot. That's going to the neck. And then the middle single coil is wired to 2, and but it's jumpered from 4 to 2 because the middle coil is in circuit through a couple pin positions through a couple positions. So that's why it's kind of jumpered here a little bit, So the middle has been in 3 different circuit configurations at this point. So that's kind of why it's jumpered there. You're going to have to go back and take more of a 10,000 foot view of it to kind of see all the jumpers and how they all work, and really have to study the super switch. But it kind of gives you an idea. This is like a basic idea of how things are working. Okay, so this is the last position, the neck single coil, and you can see that the selector switch is to the front of the guitar now, so it's all the way forward. Of course, the neck single coil is still grounded to pole 3. That hasn't changed. That's been grounded the whole time. And it was connected to 4 in the last diagram in position 4. It was still connected there, the hot lead, on pole 2. But now we still need it to be engaged, but we need to disengage the middle coil. So we just have to see that little jumper there is what enables that. So on pole 2, the common is hot. Once again, that's 0, and it's jumpering to 5, and 5 is jumpering to 4. So this is kind of what the circuit looks like for the next single coil. So that's all 5 positions, and the next video, part 2, will be the actual physical hardware wiring of the circuit, kind of show you what that looks like, and then part 3 will be the tonal qualities of the different positions, and then a little demo. So stay tuned.